And so, yeah, we will be presenting our topic, enhancing LLMs in for Gujarati language particularly. So I'll just start with one story, okay, and how it came as an inception of Gujulama. Okay, so it was an ordinary day at Routal.ai. Dixit, me, and one of our also former colleague, Dhruv Bhatnagar, who is also not right now here, but he has joined online. So we were just grinding out our work and doing some conversational AI things and debugging some our models outputs and everything. What I'll just give you one a brief detail about what Routal does. So it's a conversational AI platform which gives the HR recruitment sector a chance to chance to connect to the candidates. Okay, provide jobs. Okay, so those people who are kind of living in remote areas and those who are unemployed in some position, HR recruitment sector can help out to those people. Okay, so particularly we are also kind of focusing on white collar jobs and blue collar jobs. So at that day, we had set up one campaign for blue collar job. Okay, now blue collar jobs are basically like a labor skill job who are not able to convey properly in English or something like that. So that was our first campaign back in like October of 2023. So at that day, we started the campaign, we launched everything. Some of the calls went well. English was it was kind of going well. 5 calls we tried and it was working well, but one of the person on the other end uh, tried to talk like क्या आप हिंदी में बात कर सकते हैं. Okay, now the campaigns were configured in English. Okay, so the model isn't supposed to respond in other languages. So uh, yeah, sorry, I forgot the yeah.
Can you please share your screen?
Okay. Okay, sorry for that minor interruption. Okay, so yeah, this is the thing right here. We have built Gujulama. Okay, so I'll continue where I left off. So yeah, so as it was going on, we were kind of debugging those things where candidate were responding in those certain ways. We were not, we don't know what to do at that time. We didn't know. Actually, we were kind of confused at that time, but the campaigns had to go on. So at that time the model responded something. So it's kind of a true story. Okay, so if you some of the people are Shark Tank fans or have seen this scene all right here where Namita Thapar is saying ye meri expertise nahi hai. Okay, then LLM kind of mimic that same response like I'm sorry but I'm not able to answer that currently. I don't know Hindi languages. You can only speak in English. Okay, so at that moment on our calls were started to drop a lot. So we kind of then embarked upon this project of Gujulama, particularly, where we kind of decided that it's time for us to Indic community to take over, kind of in Indic AI space. Okay, at that time. So why not just let's just say I settle for how are you? Okay, in Gujarati we can kem cho majam, right? So why not do that, right? So LLM can actually say those things, but but uh, but actually it's kind of a difficult thing to say. So yeah, we tried and we have kind of developed something and we will going to put something over here. Okay, so yeah, man, this is our team. Okay, me Khyat, ML engineer Rutal, for working for like 2 years. Dixit Trivedi, who has been the most senior person over there, like working as a 3 years person. The last one is Dhruv Bhatnagar, who's not here right now. He's watching us from Bangalore. Yeah. So he was also has a 2 years experience in NLP. So yeah, he was also a core personality developing this Gujulama product. Okay. So I'll jump right into it. first of all, we have heard some of these players right now in the Indic landscape of AI. Okay, first one is Krutrim. Krutrim has already developed one huge ecosystem right now in India. Okay, if you have explored some of his products, you can go forward it, because they have actually published their free APIs of speech to text, PTS, lots of things. You can check it out, Krutrim.ai as well. Okay, we have also used the cloud platform to actually fine tune our own models. Okay, so you can actually also check that out. They are also giving you 10,000 rupees free credits. Okay, so you can go ahead and check that out. The second one is it's kind of a cryptic is the AI for Bharat logo. Okay, AI for Bharat is a community which was just incepted a few months back, actually, and they are making actually tremendous work in AI right now. Okay, they are going to some remote places to collect the data for some people, if the languages which Indian dialects, which are actually the data sets which are not available right now for the people like us to develop more models. They're actually collecting data from those remote places as well. So they are doing some awesome work. Third is Kisan AI. It's an old player, actually. It came in back in 2023. They developed one chatbot for particularly for agriculture purposes. Then Server AI. Server AI, you might have heard about it. They're also a huge player in Indic AI. They have also developed particularly lots of open source models as well, particularly audio decoder models. So you can check them out on Hugging Face as well. And the next one is Bharat GPT. Bharat GPT has been acquired by Geo. Okay, and they have developed one model which is known as Hanuman, but they haven't actually revealed anything yet. Okay, they are kind of like integrating the LLM into the Geo ecosystem. Okay, so we might see something in future, but we don't know anything right now. And the last one is Sutra. Okay, now Sutra is a huge one. Okay, they have actually set up their headquarters in Silicon Valley. Pranav Misri, if you have heard about it, the CEO. So they are actually working on more than 50 languages. Okay, one model can handle more than 50 languages. It can accommodate our whole entire Indian dialect and other global languages as well. So if you heard about mixture of experts algorithm, okay, so their model is based on upon that algorithm. So you can actually check out the technical report. Actually, they haven't published the research yet, but it's a good one. You can check that out as well. Okay. So first, I'll talk about the agenda of the day. So first is the roadmap, how we actually built this thing. Then we will dive into a bit difficult portion of the evening. Tokenization training, pre-training, how the data is getting prepared for pre-training as well as tokenization, and then comes upon the fine-tuning. Okay. Now the last four sections: benchmarking challenges, and how we can overcome those challenges. So these are kind of uh, quantifiable. We can say we will be presenting our model's performance over here. Okay, so these are our agenda of this evening. So first of all, I'll like to address some of the challenges that we have faced, and also currently Indian AI developers are currently facing. Okay, so first is the lack of high quality data set. Okay, so right now, as I said, AI for Bharat is actually proving to be the one who is actually developing one of the beautiful data sets they are. Okay, but at that time when we started this project back in November of 2023, we actually didn't find any kind of particular data set which are specifically for Gujarati language. Okay, or any other Indian dialect. Okay, so yes, we can use some of the like websites, Wikipedia or anything like that. We can crawl some websites and gather the information, but it would take a huge amount of time. Okay, and we had find some of the data set, so we will showcase those things here as well. But yeah, those data set actually, if they are high quality, then it's good, because this is a very essential thing because of pre-training. Okay, since the pre-training is the first stage of enhancing our LLM into particular knowledge, so that it can learn better. Okay, so that's why we need high quality data sets. Okay, second one is the limitation of vocabulary. Okay, in our existing models. Now, as I said that we have experimented on Llama 2. Okay, So Llama 2 particularly hasn't doesn't have the expansive vocabulary, okay, in for English language, sorry, Indic languages. Okay, so we'll show you the stats in the later slides, but yeah. So why we actually chose Llama 2, I'll just share you briefly. Because at that time, back in November 2023, and Llama 2 just came in July 2023, and it has like a benchmark that the model has showed us. It was tremendous. Okay, it was like on par with GPT-3. Okay, at that time, so on par, not going over. But yeah, Llama 2 was extremely doing well at that time, and no open source models were like that. So we had decided that that was the one. We will choose it. We will try and increase the vocabulary, and we'll try to integrate some kind of language that so that a model can understand. Okay, so yeah, the Llama 2 hasn't doesn't have any kind of vocabulary at all. Its majority is focused on English. Okay, so vocabulary is another thing. Okay, so, and the third one is lack of evaluation benchmark. Now let's just say you have developed an LLM, okay, for a particular language, but how will you evaluate it? That's the main thing. Okay, so now evaluation benchmarks for Indic languages are rarely scarce. You won't find anything right now that are, for particularly for Gujarati language, Hindi language, whatever. But yeah, the developments are being made. If you have heard about cognitive labs, so they have developed one Indic eval suite, okay, which was like few months ago. So they have developed that, and they have integrated Gujarati, Marathi, Tamil, Kannada, so multiple evaluation benchmarks in it. But this is a very huge requirement for every one of us, that evaluation benchmark should also be there. Otherwise, we won't be able to, provide our LLM to show the public that it's actually working. Because everyone right now is looking for evaluation, and very thorough evaluation. Okay, no one will believe if we fail in this particular step. Okay, so yeah, these are the challenges that we are facing right now. Some of them has been resolved, but yeah, so that's me. I'll call Dixit Trivedi. I will give you the entire roadmap of how we have developed the Guju Llama. So yeah, Dixit.
So yeah, thank you, Khyat, for setting a stage with the motivation behind the Guju Llama. So yeah, it's a necessary part to understand the problem, understand like the problem. Okay, before I jump into the our main content of the talk, I would like to thanks this college, because like around 6 years ago, I have attended like a 2 days workshop of the machine learning here, and I got the motivation, and I got the idea about the machine learning terms, and the machine learning algorithms. And yeah, also I got motivation to pursue my career in this field. Okay, and yeah, currently I'm here as a machine learning engineer. And yeah, I would like to thanks Ankush sir as well. So yeah, now let's jump into the ARM talk. So here is the roadmap that we have followed to build the Guju Llama. Okay, so the roadmap includes tokenization, then pre-training, then fine-tuning, and benchmarking. Okay, so tokenization is basically a breaking a sequence, breaking a data into the words. Okay, meaningful words or meaningful tokens, we can say. Then pre-training is a training a model on humongous data. Okay, or we can say unlabeled data. So then fine tuning is also like a training a model, but on label data. And after that, most important part of the whole process, which is a benchmarking, or we can say evaluating. This is the important step. So through this step, we can get the idea about our model, like in which area our model is not performing well. So yeah, this is the our roadmap. We will discuss about these all the modules one by one. So yeah, first off, tokenization. So tokenization is a process where converting text or breaking a whole sequence or a text into the meaningful words or meaningful tokens. Okay, so why we need to add this layer, why we need a tokenization. So basically, through this tokenization, we get a meaningful tokens, and model can get a better output, okay, to find the under relationship between those words. And also tokenization handles rare words. So yeah, here is the yeah, we have mentioned one image which is like a we love NLP. So after the tokenization process, it will be like we comma love comma NLP. Okay. So yeah, like there are various method for the tokenization, like different models utilize these methods for their tokenization. Okay, so like there are sentence piece, there are tick token, there are word piece, there are BP, byte coding, then white space tokenizer, then hugging space tokenizer. Yeah, it's like fast tokenizer and anagram tokenization. So these are all the methods of the tokenization. Okay, so like the working is the motivation behind the all of these tokenization is to converting like whole sequence into the text, meaningful tokens or meaningful words. Okay, so yeah, sentence piece. So like I will tell you about like how tokenization works. Okay, like under the hood of the tokenization in general. Then we will discuss about the work. We will discuss about the sentence piece, like how Llama 2 is utilizing sentence piece for their tokenization. So like after the sentence, okay, we have a whole sequence, we have a data. So after the tokenization, first tokenizer will add the layer, okay, which is a pre-tokenization and the normalization that that will be converted into the list format. Okay, just like here we love an NLP. So after that, these words will be, these meaningful tokens will be converted all mapped with the vocab file. Okay, so we'll talk about the vocab file. Vocab file will return the index. Index means like a location of the location of the meaningful words. So our model cannot understand the like this format. Okay, like we love NLP, but our model can understand the tokens like indexes. Okay, indexes of the vocab file. Yeah, so let's talk about the vocab file first. So yeah, like vocab file is a
Yes, they do. They are also available on Amicus. Okay.
sorry.
We have that. No, you can just say. Answer.
Okay. Now, yeah, like Servam AI's model, like which is open Hathi, it's open source now, but the rest of the models are not open source. They have released a one model which is called, I think, a Suka, which is encoder of the audio, like audio encoder based model. They have released, but the rest of the models are not released yet. So yeah, let's talk about the vocab file first. So vocab file is a dictionary formatted file. Okay, dictionary formatted data where our keys are are tokens. Okay, keys are the words or meaningful tokens, and our values are the indexes. Okay, indexes of we can say like indexes are a location of that token in the vocab file. So yeah, here we can say we have mentioned here just like here uh, SEHTER. This is the token, or this is the, we can say, meaningful word, and this is the location of the word in the vocab file. So through this vocab file, we will we can get the indexes. Okay, we can get the indexes, and we can pass these indexes to the model. So yeah, like here I have mentioned some details about the vocab file also, like each token assigned with a unique ID. Okay, and vocab file ensures the consistency of the like how
Hello. Hello. Are we audible?
Yes, yes.
Cool. Sorry for the
No
interruption.
worries.
Let's resume.
So yeah, I was talking about the vocab file. So yeah, I have mentioned here like the quick brown fox. So yeah, tokens are the comma like quick comma brown comma fox. Okay, and the index is that fetch from the vocab file. Okay, that is like 512 1033 981 then 284. So like this is the our like last output, final output of our tokenization. So yeah, like sometimes what happens, sometimes like tokens are not in the vocab file. Okay, just like what I say, like can't. Okay, can't word is not vocab file. Okay, then how tokenizer handles this word. Okay, so they will break the word. Okay, and even if like after the breaking the word, that word not present in the vocab file, then how tokenizer will handle this like word. Okay, so they handle like there is a like a method, there is a encoding which is a unicode like UTF-8, what we know. Okay, about so unicode transformation format in like 8-bit. Okay, so it's a character encoding method, it's a character encoding. So like every character of the token, just like a cannot. Okay, so C will be just like in the cannot word, C will be converted into the UTF format, then A will be converted into the UTF format, just like all these all like just like all the characters will be converted into the UTF format. And also, so yeah, here is the UTF format. So here is the Gujarati sentence, like શું ભારત વર્લ્ડ કપ ટ્રોફી સુરક્ષિત કરી શકશે, and can India secure the World Cup trophy? Okay, so here we can see the UTF format. Okay, UTF format of the this word. Okay, UTF format of this word. Then yeah, we can see like this tokenizer can handles English sentence. English sentence is English tokens, just like here. Can India secure the? But here, like here is the catch. Like model tokenizer cannot understand the UTF encoding. Okay, but like tokenizer needs to tokenize the text, because tokenizer cannot pass the text. Okay, tokenizer cannot pass the tokens. So like tokenizer needs to convert the whole sequence, or we can say the whole sentence into the like tokenized format. So this is the like out of vocabulary case. So yeah, just like Khyat bhai has mentioned about the Llama 2, just like we have utilized the Llama 2 for our Guju Llama. So yeah, we have found out like in the vocabulary file that there is a no Gujarati words, there is a no Gujarati tokens in the vocab file, or we can say there is a no Indic tokens are there in the vocabulary file. So what if we pass a like Gujarati sentence or a Gujarati data, then it cannot convert into the tokenized or index format. Okay, so just like here we can see Gujarati sentences, Gujarati data will be converted into the UTF format. Okay, just like out of vocabulary. So here is the token distribution by the like language in the Llama 2. Here we can see like out of 100%, like there are 84 percentage of like vocab file like is in the like English language base. Okay, like around like Llama 2 tokenizer includes around contains around 32,000 vocabulary. Okay, then out of 32K, there is a 70K, like 27K is based on the English language only. So rest of the are maybe a European language or like Asian languages. So what about our Indian languages? Like yeah, so here we have mentioned about like Tamil, Hindi, Gujarati, and the Marathi. So like Tamil language, the ratio of the Tamil tokens are just only 19, which is only 0.06 percentage. And just same about the Hindi and the Marathi. There are only 39 tokens in the vocabulary file, which is around a 0.12 percentage. It's a really like less number of, we can say. And about the Gujarati, there is only one tokens. There is only one token of the Gujarati language. Yeah, it's a 0.00001 percentage.
What is that token?
No, it's just brackets. So yeah, like about the sentence piece, like Llama 2 tokenizer, Llama 2 tokenizer based on the sentence piece tokenization. Okay, so it's as I mentioned earlier, it's like one type of a method, okay, of the tokenization. So now we will see how sentence piece tokenization works, okay, under the hood. So first of all, like a sentence piece like tokenization, okay. Tokenization, in this tokenization process, first the whole sequence will be converted into the tokens, and the tokens will be converted into the characters, okay. Just like for the cannot, okay, C comma A comma N comma T, okay, just like this way. So it will be converted into the characters. So after that, a merging part will be happens, okay. So for the merging part, Llama 2 tokenizer uses a sentence piece tokenizer uses two ways. Like one is a BP based, like which is a byte pair encoding, and the second one is a unigram model. So we discuss about these two. So BP, like a byte pair encoding. So in this, like how this algorithm merges the characters, okay. And yeah, also this sentence piece is a subword based tokenization. Okay, so yeah, let's talk about BP first. So BP, like byte pair encoding, like how it works. So it merges the characters based on the like most frequent pair. It merges the characters, okay, and prepare a list of the vocabulary, and yeah, just store into the vocabulary file. And based on this count and most frequent pair, it will merge the characters. It will merge the pairs, and it will give us the tokens, okay, or meaningful tokens, like meaningful words and the tokens. So and about the our second method, which is a unigram based. So yeah, there is a same method for the splitting the characters, and after that, how like unigram model merges the characters. So in this, it will merges based on the like a maximum likelihood, okay, maximum likelihood of the pairs. So based on the maximum likelihood of the pairs, it will merges the like pairs, and yeah, give us the tokens. So this is the two method, but in the in our Gujulama, we have utilized a unigram model. So yeah, after that, all we know is after the token will be mapped into the vocab file, and we will get the IDs. So like why we need a tokenization? Just we have see here. Just we have yeah, see here. We can see here Indic tokens like Tamil 19 or 0.06%, Hindi 0.12%, Marathi 0.12, and Gujarati 0.0%. Okay, so if like as I mentioned earlier, if we pass the like Gujarati data to the model, then model cannot convert it into the like tokens, and yeah, and also IDs, because the Gujarati tokens are not in the vocab file. So like what we can do, we can extend the our vocab file, okay. And like how we can extend the vocab file. So for that we need to do training, okay, like tokenization training. So yeah, like that's why we done the sentence piece tokenization training. So yeah, about the data requirements. So for the data requirements, we have gathered some Gujarati data, and yeah, it's also like humongous data. So for that, we have prepared a text file, and that's about our data. And yeah, about the parameters, we need to set the parameters. Okay, we need to set the parameters for the training purpose, like about the vocab size. We need to set a size. Okay, we need to like it's like a 16,000 or 20,000 or 3,000. It's based on our data, or it's based on our language. Okay, so based on our language we can set the it's like we can set with we can try with, we can start with the 16,000 or 20,000 or 3,000. So it's like vocab size. Okay, so like it's all like it's unsupervised based algorithm, where more like just like as I mentioned earlier about the process of the sentence piece, it will it will learn to like merge the tokens, and yeah, prepare a vocabulary file, just like we have said. Okay, a vocab size which is 16,000. About the model type, so yeah, as I mentioned earlier about the two methods, a unigram and the BP, but we have used the unigram method for our tokenization. And yeah, after that, character coverage. And yeah, like as I mentioned earlier, like llama 2 tokenizer is like 32k tokens. And yeah, after the training we got around like 48,000 tokens, because we have set 16,000 as a vocab size. So yeah, like after the tokenization training, we got the like good results. So here is the llama 2 tokenizer, and yeah, here is the Gujulama's tokenizer. So here we can see like our model can tokenize the text, and our model can fetch like tokens or fetch the index from the vocab file. So yeah, this is the results of tokenization training. So yeah, this is the what, like in the world of AI, tokens are the small pieces, like small, and are that the small pieces that make a big ideas possible. Yeah, like it's not like Surakshit will be converted into the secure or synonyms of the there. Okay, like what I say, like synonyms of the Surakshit in the Gujarati language, but just it's like tokenizer just handles the merging part. Okay, merging part of the characters, and like dividing part of the whole sequence. So Surakshit will be if there are synonyms of the Surakshit, that it will be not converted into the this word. Sorry.
Yeah, it is.
Yeah.
Yeah. What's the question? Yeah. The thing is that what the tokenizer actually does, it maps a particular character to a vocab file. Okay, now the secure word is actually in the vocab file. Okay. Then it actually matches to that particular index in the vocab file, and it actually shows you there. There is no particular synonym, antonym, anything like that. Okay. So also like that, Gujarati Surakshit word would also be there in the vocab file. Otherwise, it would show us the characters like that.
Just a UTF format.
If the character or word
Tokens.
does not exist, then it would just UTF-8 format would show, like an unknown token.
Basically, this is the formation part of the vocab file, and this is not yet the exact mapping to which the training will go on. So
No, this is just a mapping part. Yeah.
this is the mapping, but in future, if there are more words that are similar to, or maybe they happen to be synonyms to the word,
Yeah.
they'll be added to the vocab file, and then in the future
We need
they
to
might
do
be
training.
interchangeably.
We need to
But
do
that
training
is the
for that
manual
data.
task.
Exactly. So, like the question was going on. The question was that there might be other synonyms to the same word. So in that case, in the future, if there are other words that are synonym and added to the vocab file, then they would be mapped accordingly, and then during the training, it would understand. That
Yeah.
Of course.
The index will be
Yes.
changed. Index will be alive. So yeah, like after the tokenization, like a pre-training. Okay, so pre-training is like training a model on a humongous data. Okay, so basically there are two types of pre-training, which is like traditional pre-training and the continued pre-training. So like when we use a traditional pre-training and when we use the continued pre-training. So like when we are training a model from a scratch, okay, and when we have a general data, okay, general data, not a domain specific data. At that time we can go with the pre-training. So in the pre-training, model will learn to understand the language, understand the linguistic features, okay, nuances of the linguistic features, and the grammar about the language understanding. So based on that understanding, yeah, it will generate or so pre-training. Like as I mentioned earlier, there are two types. Okay, so for the if we are scratch, if we are training from a scratch, okay, then we can go with the traditional. And if we continue the pre-training, just like if we have a domain data, okay, domain specific data. If suppose I'm in healthcare data and I have too much data of the healthcare, but it is unlabeled data. So at that time, we can go with the fine tuning. But if we have a domain specific data and if our data is unlabeled, then we can go with the continued pre-training, which is a CPT. Okay, and yeah, we have used a CPT for our Gujulama because we had a data of Gujarati language, or we can say it's a language specific or a domain specific. So for that we have used a CPT.
I have a question. Let's say we are adding a new language support, right? Something that model doesn't identify, right? So clearly there will be tokenization in the tokenization step. Can we say that CPT is a necessary step? Like it will always happen whenever we are adding new
No,
language
it's like we are adding a knowledge. Okay, we are adding a knowledge, or we are training a model on our data. Okay, so for that there are multiple ways to do same. Okay, such as a reg, such as a zero shot, few shot, like prompting. Okay, zero shot, few shot prompting, then fine tuning, then pre-training. But if we have a unlabeled data, or and if we don't go with the reg, because the reg has their own pros and cons. So like generally researchers suggest this method if you have a domain specific data, and if you want to add like a new language data. Okay, and so for that we need to train a tokenizer first, then we can go with the CPT. Okay, so yeah, this is the pre-training. So like why we need a pre-training, a language adaptation, then like a lack of resources, like unlabeled, like we have a lack of unlabeled data, lack of a label data, then domain adaptation, then like preventing catastrophic forgetting. So like we will discuss about this in our later slides in the fine tuning. And after that, no label data. So for that we can use a pre-training. So like pre-training is a unsupervised based algorithm. So yeah, like pre-training algorithms, like we have mentioned different algorithms, like a causal language modeling, like CLM, then masked language modeling, then permuted language modeling in the XLNet, denoising autoencoding, NSP, then span masking, then sequence to sequence pre-training. So these are all pre-training algorithms. Okay, so like in the llama 2, in the GPT-4, in the GPT-3, mostly like decoder only models uses a CLM for the pre-training approach. Okay, for the pre-training is a pre-training algorithm. And like BERT, Robota, Albert, so they have used the mask language modeling for their pre-training to like pre-train the model. For the XLNet, they have used the PLM. For the debutta, they have used denoising, the autoencoding. So these are all unsupervised based algorithm. And yeah, we will see how the this algorithm works. So yeah, like before that, we have utilized a run pods, a cloud GPU for the pre-training purpose. So for that we have used the NVIDIA A100, and yeah, like for the around 80 GB. The GPU was around 80 GB, and the RAM are like 117 GB RAM. You can utilize this for your project, or if you don't have any GPU and if you don't want to go with the collab, then you can utilize this run port. There are Krutrim also. Yeah, like about the about the like pricing around we have I don't know about the pricing actually. I'm not actual number, but yeah, it's around like $1.82 at that time per hour. So yeah, about the data utilization. So like as I mentioned earlier, we need a humongous data to train like to pre-train the model, okay, to or we can see a continued pre-training, okay. So for that we have utilized Cultura X data set. So Cultura X is like a storage, or we can say a multi-language data set. We can find our data, we can find our Indic languages data of like on there, about the Tamil, about the like Odia languages, Gujarati, then Marathi. So here I have mentioned about the like data link, and yeah, the size was around 1.1 million documents. Like we can say 1.1 million records, okay, or rows we can say. So from this number we have utilized around 500k documents. Just like for like lack of resources, we have utilized half of them. And yeah, this data is the unlabeled data, so that's why we are utilize this data into the pre-training. So now we will see like how like CLM works, okay, how under the hood of the CLM. So this is the algorithm. So a model will predicts the word. A model will predicts the word based on the left context, based on the previous word. Model will predicts the word and learns to predicts the word. Okay, next tokens, and just like this way, it will learn. It will learn to understand the language. It will learn to generate the languages, generate the next token, and yeah, that's why like CLM is a famous method for the generation model, or we can say decoder only models. So here I have mentioned like few steps, like start, then tokenization, then the content preparation. The content preparation is like a left context, or we can say a words of the left context. So based on this left context word, it will predict the next word, and yeah, after that it will check if this word is similar to the actual word or not. If it is not, then yeah, it will do some updates the weights, or do some changes in the weights, okay, in the layers. So after that, if it is that word, okay, if it is that word, then it will add to the it will append to the list, and yeah, based on the list or the context, it will predict the next word. So just like this way, like a whole uh, like CLM works, like append the predicted word into the sequence. Then here we can see like update the context with the new word, then a loss calculation, then yeah, repeat the same process for further pre-training. Yeah, this is about the CLM.
Can you also explain how much time it will take to pre-train the model?
Yeah, so yeah, about the timing, so it's around 56 hours. So it's around like 56 hour in the A100 GPUs. So it's like batch wise, it was like a batch wise pre-training. So yeah, around a 56 hour.
Can you say that like roughly how much time it will take to repeat the
Yeah, we
same
can say it's like around 100 or $150.
10 times repeat?
Yes. So yeah, like this is the process, like this is the like two modules of the Gujulama, that like how we build. Okay, like first one is a tokenization, and the second one is pre-training. So yeah, after the pre-training, there is a like another module, fine tuning. So for that, we like
After a short break. So thanks, Dixit, for that informative knowledge about tokenization and pre-training. It was awesome. Yeah. So next step after everything that we have performed, tokenization, pre-training, all that jargons that we have faced, and those difficult tasks like pre-training and tokenization, they are very difficult to do actually. Okay, so now they're out of the way. We are now focusing on the fine tuning. Okay, so basically I'll just give you the glimpse of fine tuning. Fine tuning is basically like telling the model to do something. Okay, now in what happens contrary to pre-training is like we are feeding the structured unstructured data. There is no instruction, there are no labels, nothing, just we are giving just some chunks amount of data into it and it will learn from it. Okay, so now comes the part of how we can use that unstructured data that model have learned to actually purposefully to do some to actually instruct the LLM to do something. Okay, yeah. So this is the workflow. First of all, just an overview of a bird eye overview of how we can actually utilize a fine tuning process. First is the scope. Let's say we want to summarize something. Okay, the model we have just prepared right now doesn't know how to summarize. Okay, the task is to summarize. Now the first is we need to define the problem. Okay, it can be anything. This is not just limited to one task only. We can actually define multiple tasks here: summarization, translation, whatever we want. Okay, so that's the thing. First define the problem, then move on to the next one, choose the model. Okay, now if you are hell bent on selecting the open source model, then yeah, it's kind of a difficult thing to do here, because there are lots of open source model who are really doing some good things right now. So we have, as we have selected Llama 2, we'll talk about Llama 2 over here, but it's all upon you, it's all upon your research. Okay, so choose the model which is fits right for you. Okay, then we'll come on to the adapt and align. Okay, once the model has been selected, you you know about everything about inside and outside about the model. We can come upon prompt engineering. Okay, we need to learn how that particular model actually learns the prompt, because like Llama 2 actually learns the prompt differently. Okay, it has some instructions, it has some tags that actually follows Llama 2, because without those tags, without that particular characters, it cannot actually uh, work quite well. Okay, so first learn like inside is prompt engineering, how the Llama 2 actually has defined their prompting techniques. Okay, and next thing is fine tuning. Once those prompting techniques you have learned, you can actually integrate those things in your instruction tuning data. Okay, and then go forward with the fine tuning. Okay, now then comes the part of evaluation. So I'll actually align with the human feedback will come after it. But once the fine tuning has been completed, your task has your model has learned about summarization, translation, you can actually evaluate the model now. There are lots of evaluation suites are available on the Hugging Face and open source suites. So you can evaluate the model for particularly summarization, translation for any language that you want. If the evaluation falls short, you can jump into the align with human feedback. That is the RLHF. Okay. Now the thing is the RLHF. It's a really huge concept to explain here. But I'll just give you the glimpse of it. So like it's like teaching a baby. Okay, like teaching a kid to learn something. Okay, like it made some mistake. We will either not scold him, but we'll actually tell it to perform something better. Okay, to actually drive its behavior into something else. Okay, that we want. Okay, that is the align with human feedback that actually we are giving to it, the human feedback. Okay, that is the RLHF. Okay, so that is the adapt. First adapt the model to particular task, then align it, then again evaluate it. This third one is actually kind of ongoing process. Okay, so once you get the evaluation score correctly, then you're good to go. Okay, so suppose you have got your summarization task, the translation task, all very well. We can jump into the application integration part. Okay, now we can actually optimize our models. We can deploy our models here. Okay, for inference part, suppose if we are productionizing our model somewhere, we can develop an API. Okay, we can show it to the public. Okay, so that is the one thing. In optimization, suppose if the model is generating pretty much slower, you can use quantization. Okay, you can make the model smaller so that it can generate tokens a bit faster. Okay, and then comes the VLLM library. I don't know if you've heard about that, but VLLM is a library that can adapt the model to generate tokens faster. Okay, so it's another thing. And then you can augment model and build LLM powered applications. That's it. That's the use case. Suppose if you have developed the summarization application, you can actually publish the API somewhere where you can generate the money for your own, or just play it for fun. Okay, so or also you can develop some kind of chatbot as well, and you can show it to the public. So yeah, that's the whole gist of the workflow. and we'll talk about the practical approach. Okay, so how we can achieve the instruction tuning. First is, like I said, figure out your task. The task has been defined. Then collect data related to the task input and output. The task for summarization we have already gathered. Instruction has been constructed. The proper outputs also are there. Then that data has been ready. Okay. So suppose now sometimes it happens, like in our case it has happened, like sorry. So we didn't find pretty much not enough Gujarati data. So we had to use Gemini, okay, Google Gemini. So to translate English data into Gujarati, okay. So because we didn't find much data for instruction tuning at that time, but nowadays it is in abundance. So we can actually generate the data using any of the pre-trained large models which are there, GPT-4, Gemini, Anthropic's Claude, or you can also use Llama 3, 4, and 5 billion model as well, because those model can give you some good outputs. Okay. So yeah, so you have the data collection ready, everything is done. Now it's time to fine tune. Okay. Now here you can actually, you don't need to jump into the bigger models right away. You can try out some small models first. Okay. If small models actually filling out your purpose, then you can go ahead with the next steps. Okay, like vary the amount of data you give the model first. Okay, then comes the part of evaluation again. Okay, of if it's working perfectly or not. If it's not, then collect more data. Okay, we can collect more data. If the evaluation still fails, increase the task complexity. Okay, now in summarization you can actually provide some different way of instruction to summarize the context. Okay, so that is so that it can learn from different complexity of task. Okay, if that doesn't work as well, you can then increase the model size. Okay, you can go forward with the LLM rather than SLM. Okay.
So when you say the practical approach of instruction tuning, in the previous slide we saw the workflow for fine tuning, and in the middle part that was align and
Align and adapt.
Align and adapt. In that, the first part was the prompt instructions and that part. So if we are already including the prompt and instructions in the fine tuning, then how would instruction tuning be different from fine tuning? I mean, if it is
it's the same thing. It's the same thing. It's just we are providing this instruction over here. Well, I'll let you know about the rules of. I mean, there are some other terms like full fine tuning and all that will come in the later slide. Okay, so
I just want to know that this is a separate discussion, or this is placed in somewhere in the previous diagram.
Actually, it's kind of same thing actually. But I also, one thing I haven't included is the RLHF one and the application integration. Otherwise, this is all the everything is the same here. Okay, this is just to show some bullet points. So that's nothing else.
So if I understood it right, instruction tuning means we are like
providing some instruction. Okay.
Basically, the model would be the same, but you are trying various instructions and see how it responds.
Yeah, because we are actually want the model to obey some instruction, right?
So then we are not actually making changes to the model. We are adjusting the input so that we get the necessary output.
Yeah, you can say that. Okay, so that's the practical approach. So suppose you are actually preparing the data. This is how we can actually prepare the prompts. Okay, so this is first one is classification prompt, like if you have a hotel review or if you have a food or restaurant review, you can just follow give the particular instruction given the following review. Now here, this is the part, this is the context. Okay, this is the context which LLM is going to learn from. Okay, like what kind of review it is. Okay, so from this context it will predict a rating from 1 out of 5. Okay, so this is just for learning. Okay, this part we actually need to feed the LLM so that it can adapt to a particular set of instruction, or you can say particular type of data. Okay, next is text generation. Okay, now here is it says a generate a 5-star rating review about this product. Now what happens is, this is just like you are asking GPT, like I have purchased the product. Okay, now I want you to suppose if no one knows English. Okay, now they are kind of reluctant to type or anything, they don't want to spend much time in typing. So over on let's just say Amazon, you have purchased a product and you want to give a 5-star rating or something like that. You want to give a worst kind of rating as well. So you can actually prompt the LLM here. Okay, you can actually say that can you please generate for this particular product kind of a review, so that I can post somewhere. Okay, that is the text generation part. It is kind of like learning from the context that we are providing in the instruction itself. Okay, it will generate a whole bunch of text, like it will this part right here, it will only generate a small chunk of tokens, like 1 to 5 rating, nothing else. Okay, here it will generate a bunch of text for you to paste somewhere. Okay, next last one is the text summarization. Okay, we can give some kind of a context of a body, and it will give some kind of, let's say that I'm giving 10 lines of paragraph to it, and I'm just saying that give me a short sentence describing the following product review. Okay, so it will, what it do, it will compress those 10 lines into say one or two lines. That's the whole purpose of summarization. Okay, these are the prompt templates that we actually need to prepare for instruction tuning. Okay, now there comes the part of instruction tuning. Okay, so instruction tuning is I just say it's a task agnostic. Okay, so without a specific task, a pre-trained model cannot actually learn generate anything. Okay, so instruction we need to feed some instruction based training data here. Okay, so particularly input and output pairs, instruction and its supposedly output. Okay, so that it can learn from it, like translate the following text into Gujarati. This is an instruction, and this is you can say kind of a label. Okay, whatever is supposed to generate. So yeah, and improve generalization. So in instruction tuning, there is one thing that you can actually provide single instructions for fine tuning. You can also provide multitask instruction as well, so that it can generalize better. Otherwise, what would happen, that it model just fall short and learn only one thing. Okay, so what we can do, if we want to push the model to the public, we can generalize it to a much better instructions. Okay.
So,
Yeah.
instruction tuning is just like a prompting. We are just giving a prompt to the model and instruct it to give the output as supposed I want. It's just like that.
Yeah, you are actually giving some kind of prompt, and you actually want some kind of output. Okay, but it might not happen that it will give you always the same output or always the desired output that you want. Okay, so it's an LLM. It's a play on probability. Okay, so it can generate anything. So yeah, you can always get a desired output every time. Okay. So yeah, these are some example use cases we've already seen. And then comes supervised fine tuning. Now the supervised fine tuning here, actually what it means, like if any of you are from ML background or anything, you have already performed classification models or something like that. Okay, like label based training. Okay, a particular task has been given and its particular label is there. Okay, like sentiment classification or something else. Okay, so what it is simple here. What we would do, if we would provide an instruction, kind of a system prompt here. Okay, then comes a part of a particular context. Okay, what kind of, like sentiment, like we want to provide a sentiment for a particular review. Okay, so that context part would come next, and then comes the label part. So it's a threefold technique here. Okay, we are actually providing 3 parameters inside the supervised fine tuning. Okay, since this is label data. Okay, so since this is a task specific supervision, this data might contain RLHF specific data as well, because supervised data needs to be well prepared, well curated. Okay, we cannot just feed into anything if it's not supervised data. Okay, so so here we can do one thing. We can in SFT we can actually if we don't want to fine tune the whole model itself, like 7 billion parameters of the model is there, but we don't want to offload the model into GPU at all. We can select some of the parameters itself, okay, using parameter efficient fine tuning and low rank adaptation. Okay, these are the methodology I'll discuss in the later slides. So these are some of the techniques that we have already used. Okay, we have actually used the supervised fine tuning in our Gujulama. Okay, so you can use those techniques to selective parameter updating. Okay, only few parameters, not whole of the model. Because what happened is that in our case, when we without using PAF to low rank adaptation, our model started to forget what it had previously learned. Okay, because we were just updating all of the parameters. Okay, well, I'll discuss it in the further slides, but yeah. So this is a supervised fine-tuning case. This is NER, named entity recognition example. Okay, so Chandrayaan 2 was launched from Sriharikota on July 22, 2019. Now here what we are trying to identify, first is a mission name, Chandrayaan 2, Sriharikota is the launch site, and the date. Okay, since this is supervised fine-tuning data, we need to prepare this data first. Okay, model will not able to generalize or provide us output on the first hand. Okay, so we need to prepare this data first. We need to actually humanly label this data in order to provide us that LLM output. And then comes the full fine tuning, which is the final part of the instruction tuning, whole instruction tuning. Now, what is full fine tuning? Full fine tuning is completely opposite of what we have just seen. Okay, it actually fine tunes the data, but it only fine tunes the data on a specific task, nothing else. Because full fine tuning means we are actually performing full fine on the whole model. Okay, not introducing any parameter efficient fine tuning, not introducing low rank or anything. We are actually just pushing the instruction tune data on the whole model. What will it do? It will go through all of the layers one by one, and it will just update everything. It will even forget the previous knowledge, because sometimes it is required. Okay, I'll explain you as an example in the next slide. So task specific training, as always, it requires a very large amount of data. Okay, so in SFT and instruction tuning, you can like 10 to 15,000 data rows you can give, but here you need some requires a large amount of data here. Okay, and it's a computationally expensive. Since we are offloading all of the parameters onto the GPU, you need a big GPU here. Okay, so this is the full fine tuning gist. And like I said, suppose if you have given a task for building a chatbot for a, let's say, a hospital. Okay, so here, or a kind of like a support bot for a doctor. Okay, now the doctor kind of need to pre-screen some of the patient first, so that it can adapt according to when the patient comes into the office. Okay, so patient actually enters the symptoms first. Okay, then model will generate the label like condition, what kind of problem is he having. Okay, so we cannot actually use any type of model here. Okay, we need to actually fit entire model into medical data. Okay, it needs to perform on the medical data, it needs to make judgment on the medical data. It should not supposed to do anything. Okay, otherwise it would just it would rather produce some garbage output as well, which would might endanger patient life. Okay, yeah, so this is a full fine tuning. Now comes the part of low rank adaptation. So it's like learning a new skill without overloading your brain. Okay, now let's just say that you are actually a chef at a restaurant. Okay, and you have learned all of the Chinese, Thai, and multiple cuisine you have already learned. Now one day the manager comes in and tells you to learn Indian cuisine. Okay, so I mean, you don't need to just start learning about chopping everything. Don't need to learn about new spices, all of the spices that you have learned previously before. Okay, you just need to learn how the Indian recipe is slightly different than other recipes. Okay, you just need to make some slight adjustment, not everything. Okay, so here low rank adaptation comes in. Just pick the smallest amount of parameters. Okay, not whole model, because it doesn't require whole model. Because if your task is minimal, why should we update the whole parameters? Okay, so that's the thing. There is one small analogy. Okay, like if you are going at a grocery store, okay, to buy some milk. Now instead of using a car, instead of walk, or instead of using a bike, you're actually try to go to the grocery store via military tank. Okay, so it's kind of a small type task. Why are you making such a complicated thing? Okay, so that kind of analogy is working in the low rank adaptation. Okay, so the low rank adaptation is actually playing with a matrix multiplication. That is all there is to it. Okay, its a favorite parameter is rank. Okay, according to the rank, it actually selects these dimensions. Okay, right here. If the rank is 1, then row 1 dimension, and sorry, column 1 and row 1. Okay, and according to it, it will select those particular parameters from each and every layer of the whole model itself. Okay, so I mean, during this research paper, there was some debate, like if we use low rank adaptation, what would happen if we push the low rank adaptation into a 7 billion model? Would it just go through some of the layers of the model, or would it go through all of the layers? So yes, it would go through all of the layers, but from each layers it would select some particular parameters. Okay, then it would create this weight changes matrix. This is known as changes matrices, because it will track the matrices, okay, from every layer. Okay, whenever weights are being updated during fine tuning, okay, so those weights will be changed into these particular matrices. Okay, so let's just say that you are performing a fine tuning task. Okay, now what happens is the batch of one single data goes through every layer. Okay, and model will try to predict the particular output. Okay, now then comes the loss function. The loss function comes into the picture. Whatever output the LLM has generated, it will try to see that how far was the output from the label data. Okay, that data that we have provided, how far was it? Okay, so if the data was really far off it, the label isn't correct, it hasn't correctly predicted, then what would it do? It would just adjust the weight to particular dimension, and it would adjust the weight toward down. Okay, there is up and down. Okay, if the results are good, then it will increment the values. Okay, so that's how this whole thing works. Once a batch of data goes through all of the layers, it will merge it with the model weights, the original model weights that we have actually shifted into the GPU. Okay, so the calculation will happen on this, but whatever we have fine-tuned, whatever the data we have fed into these weights, it will merge into the original weights of the model, and it will become a fine-tuned model. That's it. That's all there is to it, because we are only selecting some of the parameters, not the whole model. Okay, using this, we can actually reduce the memory footprint. Okay, we don't need to actually use the 80 GB GPU here. We can just use a 20 or 40 GB GPU. Okay, it can work. It can reduce the memory footprint. It is also a bit faster method, contrary to full fine tuning. Okay, so that's how LoRa works. And about the rank. Now I don't know if you can see the numbers, but here on the left side, the ranks 1, 2, 4, 8, 16, and these are always in multipliers of 2. Okay, so according, let's say the rank 1 is selected, like a matrix of one column, one row. From every layer, it will select one change matrices. Okay, and from 7 billion model, it will only select 167,332 parameters to adjust. It will not change other 7 billion or 6 billion, something like that. Other parameters it won't. Okay, it won't adjust. Like on the other part, on the right side, as you can see, the percentage wise precision. Okay, only 0.002% of the trainable parameters will be selected for fine tuning for our task, and it will generalize on its own. But now let's just say you are saying that there are also these ranks are also there. So suppose if you have a large amount of data, okay, and since the data is very large, so model needs to utilize all of the layers pretty well. So what we can do, we can actually increase the ranks. We can actually increase the matrices dimension so that it can learn better. Okay, so we can go up to 512. We can actually go up to 124 or 1024 as well. But I was just according to our experiment, we have gone through a 512, and it has really worked well. Okay, so as you can see, the increasing of the rank actually the models are trainable parameters or precisions are not that much difference in there. Okay, even if you rank, but that particular data will generalize well. Okay, so that's the whole gist for rank. Okay, yeah, that's about low rank adaptations and parameter efficient fine tuning. So now comes the part we are kind of like reaching the ending of this. So challenges and possible solution, which will
Just one query regarding the low rank adaptation. So, do you use any particular library?
yeah, you can use PFT, parameter efficient fine tuning. Okay, and also Hugging Face natively support LoRa config module. Okay, so you can just what you can do is first select your rank. Okay, whatever rank actually what kind of data you have, what amount of data you have, you can select the rank accordingly. And other parameters are also there, but I haven't mentioned here because they are very much bigger. So like target modules, which layers to target. Suppose if you're not using any target modules, the model that low rank will select the matrices from each and every layer, but you can actually provide the target modules, what kind of attention layer you want to focus on, so that it can goes through that particular target module. And you also can set up task type. LoRa actually provides NER for NER purpose. Low rank actually provides a different kind of config. Also for CLM purposes, also different kind of config. Okay. So those are some of the parameters are there. You can construct that config, pass it on to the PFT library, and your adapter will be there. Just an adapter, nothing else. 500. Suppose we are using Llama 2. So like 15 GB, I guess 15 GB of the whole model is there. Okay. So from that 15 GB, like I guess 2 to 3 GB adapter, only 2 to 3 GB parameters will come to you. You can pass that on to the instruction fine tuning. That's it. Yeah, it should.
So yeah, after the pre-training, after the tokenization training, after the fine-tuning, there are some limitations of the Gujulama. There are some challenges. So and yeah, we will discuss about the challenges and the possible solutions. So yeah, we have list down some challenges that we have faced. Yeah, it's about like hallucination, repeated token generation, then catastrophic forgetting, and the latency one. So like hallucination. So hallucination, like what is the basic mean of the hallucination? Hallucination means to give incorrect like factual information, like factually incorrect information. Okay. So suppose like I we have mentioned one example. Like tell me about the Eiffel Tower in the London. About the Eiffel Tower in London. So model response: Eiffel Tower in London is a famous historical landmark near the river Thames. Okay, Thames. But the actual one is like a model hallucinate the Eiffel Tower is in London instead of Paris. So it's kind of hallucination, like model like some of them are global issues. Okay, some there are like many forms, like many LLMs are facing. So, even the Chat GPT, GPT-4, GPT-3 are facing the same challenges, and some limitations are there. So also a repeated token generation. So like at the generation point, model will like repeat the words after some extent. Okay, like here I have mentioned like the hero was brave. So model stuck in this point, and yeah, generated same tokens like brave, 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 brave. And after that, he generated everyone loud, loud, loud. So this is the one problem. And yeah, like for that we have a possible solution. So like we forgot to put a stop token in the data preparation time. So stop token helps to like model understand like where I need to stop. Okay, where I need to stop to generate the tokens. So this is the possible solution of the repeated tokens. And yeah, possible solution of the hallucination is like there are many solutions, and yeah, many researchers are working on the same. Just like reg is the one of the approach to like overcome the hallucination. And yeah, like we have tried another approach which is based on like to give a same data on a for multiple times. Okay, in the training time, in the fine tuning time. And yeah, sometimes like we got the better results, but yeah, there was a hallucination problem. And yeah, there is a catastrophic forgetting. Yeah, as the Khyat bhai mentioned earlier, catastrophic forgetting means sometimes what happen when we do full fine tuning. Full fine tuning means updates the whole layers, all the weights of the model. Then model forgets to model forgets the previous data. Model forgets to a pre-training data. Okay, that like already a pre-trained on. So like this is the like catastrophic forgetting. So there is a possible solution like there is a LoRa method for that. So we don't need to update the whole weights, or we don't need to update the whole layers of the model. So apart from that, we can use like some adapters. Okay, some adapter tuning methods. So this is the catastrophic forgetting, like possible solution. And yeah, there is a latency and the efficiency. So latency, like just a Khyat has mentioned about the SLM and the LLM part. Like we don't need to train a whole model. We can go with the quantization, or we can go with the like SLM models also. Okay. uh, Voice is breaking.
Is it audible?
Yeah, hello, is it audible? Hello.
Yes, yes.
Okay, yeah. So yeah, latency part. So like rather than like if we have a small task, okay, we have a small task for the model, then we can go with the SLM one, or we can go with the quantization method. So there is a like, or we can go with the like VLLM framework. VLLM framework is like Python library or a framework. So it helps to accelerate the inference of the model. So yeah, this is the possible solution of the latency and efficiency. So these are some challenges. Yeah, apart from these challenges, there are many challenges, and there are some limitations of the Gujulama. But here we have mentioned some important one. So yeah, here is the benchmarking part. So after the all the flow, it's necessary to identify the like where our model is not performing well. Okay, so for that part, the benchmarking and the evaluating like comes into the picture. So yeah, we have utilized Indic eval suits for the like generate the benchmarking of the Gujulama. So here we can see there are like MMLU, there are ARC easy, like ARC challenge, bull queue, and the Hellaswag. So these are all metrics. Okay, so MMLU is based on like massive multitask language understanding. So it's based on a general understanding of the language. It's a MCQ based questions. Okay, so for that, yeah, we have like we got around the 48.6 score in the MMLU, in the ARC easy and the ARC challenge. So it's ARC means AI to reasoning challenge. So it's based on the science exam, like grade 3 to 9 for the easy one, and for the challenge one it's like a grade 9 to like college level. So it's based on the science exam. And yeah, also it is a reasoning based questions. And yeah, we got around 0.43 and 0.25. About the bull queue, it's based on like yes or no based questions, or we can say it's like true or false based questions are there. And yeah, for the Hellasback, it's like common sense reasoning based questions are there. And yeah, we got around 0.40 in the Gujulama. So this is the some comparison of the Lama 2 and the Gujulama.
You can say this is a kind of aptitude test for the model. Right?
Yes. So yeah, like we have mentioned like one of the like result of the Gujulama. And yeah, we can see like it's a resignation email. And yeah, we can see some limitations of the like here, stressed. It is repeating the words. Yeah, and yeah, like a format wise, it's better. It's better than Llama 2's tokenizer. Sorry, Llama 2's model.
Yeah, because Llama 2 base model is not able to perceive the Gujarati tokens.
Yes.
It is not even able to generate these characters as well. So, I mean, I know that this model is not, perfect in every way, but it is able to understand Gujarati that we want it to do. So I think earlier it was not able to even read Gujarati. Yes.
Yes.
Now when you can't read something, how can you
Generate,
write
or you can generate it.
meaningful
Yes.
something?
So this is the result of the Gujulama.
Can you switch back?
Yes.
Well, as we see, the sentence formation is also quite good. The only issue I see with this is the repetition. And
Yes.
if that has been cleared, I think this would be a perfect resignation.
Yes, we can use this.
Yeah, you can use that.
Yeah. So like this is the like our last quote. Like why ask? Can you speak Gujarati when your LLM's already saying, "हाँ भाई बोल ही रही हो छू."
So
So
yeah,
yeah, let's time to conclude this.
yeah. So thank you for attending this particular. This is our first talk ever. What we have developed here. So in conclusion, I would like to say that the journey of integrating these Indian languages into LLMs, it's not just about enhancing machine learning capabilities. It's actually understanding the people's the capabilities as well. Okay. Otherwise, how would we bridge the gaps between AI and human itself? Okay. So that's what we wanted to try, and we kind of I'm not saying that we kind of succeeded, but we are on the right path. And also we are also conducting research on llama 3 as well, where you have also already seen the tokenization part, where we are pre-training using adding tokens into the tokenizer itself, but we are actually removing the tokenizer at pre-training part. Okay, we are not adding any kind of characters, any kind of words into the vocabulary. We are just pushing the model to learn from unstructured data of Gujarati directly. So we are trying to research that, and we have some pretty good results, but unfortunately due to resource, we don't have any GPU right now, so we aren't able to show it. But yeah, so that's all there is to it.